Hello everyone, welcome to my video lecture on thermoelectricity session 55. Discussing points, applications of thermodynamics to thermoelectric effects. The other thermodynamic relations, pi is equals to Tp and sigma A minus sigma B is equals to minus T into d square E by dt square, etc. Learning objectives. To know the applications of thermodynamics to the thermoelectric effects, to know the other thermodynamic relations, and also to derive the expression for pi is equals to T into P, to analyze the thermodynamic relations. Session outcomes. Student can identify the direction of current flow in the Thomson effect, heat absorbed at the hot and cold junctions due to Peltier effect. If two junctions are at difference of temperature dt and difference of Peltier coefficients d pi, then dE is equals to d pi plus sigma A minus sigma B into dt. And student can able to deduce the other four relations such as pi is equals to Tp. Prerequisites. To understand this concept, student must know about meaning of thermoelectricity, Seebeck effect, Peltier effect, Seebeck coefficient, Peltier coefficient, and mathematical operations simply. First, applications of thermodynamics to thermoelectric effects. Here, considering a thermocouple of two metals A and B with their junctions J1 and J2 at temperature T1 and T2, let sigma A and sigma B be the Thomson coefficients of A and B. Let pi 1 and pi 2 be the Peltier coefficients at T1 and T2. Heat absorbed at the hot junction due to Peltier effect is pi 2 I into T. So heat absorbed at the cold junction due to the Peltier effect is minus pi 1 I into T. Here the negative sign indicates heat energy is evolved or liberated. Total heat absorbed due to the Peltier effect is given by pi 2 minus pi 1 I into T. Due to the Thomson effect, heat energy absorbed in metal A, in which current flows from lower temperature to higher temperature, and heat is liberated or evolved in metal B, in which current flows from higher temperature to lower temperature. To know this, considering 2 points x and y having the temperature difference of dt in the same circuit diagram, that heat energy absorbed between the points x and y is sigma A into dt. Then total heat energy absorbed in a metal A from T1 to T2, so it's given by integral from T1 to T2 sigma A dt into I into T. Similarly, total heat energy absorbed in metal B is given by minus from integral T1 to T2 sigma B dt into I into T. Total heat energy absorbed due to both Peltier effect and also due to Thomson effect is given by pi 2 minus pi 1 plus sigma A minus sigma B into dt into IT. So call this as equation number 1. The total EMF developed in the circuit, then the total EMF, total energy produced is equals to EI into T. So call that as equation number 2. Equating equation 1 and equation 2, we get EI into T, that is equals to pi 2 minus pi 1 plus integral from T1 to T2 sigma A minus sigma B into dt I into T. Both left and right hand sides IT I is common and cancelled out. E is equals to pi 2 minus pi 1 plus integral from T1 to T2 sigma A minus sigma B into dt. If the two junctions are at difference of temperature dt and difference of Peltier coefficient d phi, then the change in EMF dE equals to d pi plus sigma A minus sigma B into dt. In another form, so if we divide dt on both sides, so we will get dE by dt, that is equals to d pi by dt, and dt get cancels, remaining sigma A minus sigma B. The other thermodynamic relations are pi is equals to T into P, sigma A minus sigma B is equals to minus T into d square E by dt square. Third one, from integral T1 to T2 sigma A dt, that is equals to T of P2 minus P1 d by dt of pi of T plus sigma A minus sigma B divided by T equals to 0. First, we are going to deduce the relation pi is equals to T into P. So consider a thermocouple of two metals A and B with their junctions J1 and J2 and the temperatures T1 and T2, sigma A and sigma B be the Thomson coefficients of A and B, pi 1, pi 2 be the Peltier coefficients at T1 and T2. T1 and T2, and here the consider a thermocouple of two metals A and B with their junctions J1 and J2 at temperatures T and T plus dt. Let sigma A and sigma B be the Thomson coefficients of A and B. Let pi and d pi plus d pi be the Peltier coefficients at T and T plus dt. Let a current I amperes flow through T seconds. Heat absorbed at hot junction due to Peltier effect is pi plus d pi I into T. So that is Q1. Heat absorbed at the cold junction due to Peltier effect is pi I into T. Total heat energy absorbed due to the Thomson effect is given by sigma A minus sigma B dt into I into T. Since Peltier and Thomson effects are reversible, thermocouple, therefore a reversible heat engines, and thus Corner's theorem can be applied for this. The heat energy appears due to the EMF developed in the circuit. Then, according to the second law of thermodynamics, applying second law of thermodynamics, Q1 by T1 is equals to Q2 by T2. So that is total heat absorbed is equals to total heat liberated in the system. So it is given by pi plus d pi I into T by T plus dt plus sigma A minus sigma B dt IT by T. So that is equals to total heat liberated in the system is pi IT by T. Here pi plus d pi by T plus dt minus pi by T. So in this IT get cancels out, remaining take pi by T on left hand side, so it becomes negative. Then the right hand side becomes 0. Next take LCM of this T of T plus dt and remaining pi T plus d pi T. Multiply this one. So minus pi of T plus dt plus sigma A minus sigma B dt T plus dt, that is equals to 0. After multiplication, so neglecting the term sigma A minus sigma B dt square has dt is small. So remaining, so pi t and minus pi into t get cancels, d pi into t minus pi into dt plus sigma A minus sigma B dt into t divide by t of t plus dt is equals to 0. Therefore, so this term goes to here, so it is also 0. Remaining t of d pi plus sigma A minus sigma B dt minus pi into dt, so that equals to 0. But dE is equals to d pi plus sigma A minus sigma B into dt. So t into dE minus pi into dt equals to 0. So pi equals to t into dE by dt. Pi equals to dE by dt is nothing but it's a thermoelectric power P. Hence, Peltier effect for a pair of metals at any temperature is the product of absolute temperature and thermoelectric power. Second one, minus T d square E by dt square, that is equals to sigma A minus sigma B. So we know that pi is equals to Tp relation. So we can write P as dE by dt and differentiating we will get d pi is equals to T into d square E by dt square plus dE by dt into 1. So dE by dt minus d pi by dt is equals to minus T into d square E by dt square. So call this as equation number 1. So dE equals to d pi plus sigma A minus sigma B into dt. We know this relation. Dividing dt on both sides to the above equation, we'll get dA by dt minus d pi by dt. So that is equals to sigma A minus sigma B. So call this as equation number 1. So observe here the left hand side is same in both 1 and 2 equations and equate the right hand side from 1 and 2. So we'll get minus t into d square E by dt square, that is equals to sigma A minus sigma B. To prove P is equals to, T1 to T2 sigma dt is equals to T of P2 minus P1. So let us take power, thermoelectric power P is equals to dE by dt. Differentiate with respect to T. So dP by dt is equals to d square E by dt square. So but sigma is equals to T into d square E by dt square. So we can write this d square E by dt square as T into dP by dt. Sigma dt, so multiply this, sigma dt is equals to T into dP. So integrating, we'll get T1 from integral T1 to T2, sigma dt is equals to T from integral P1 to P2 dP. So at last, from integral T1 to T2, sigma dt is equals to T of P2 minus P1. Here, the Thomson effect is equal to, for a given metal, is equal to the product of the difference of thermoelectric power at the ends and the mean absolute temperature. Fourth one, d by dt of phi by t plus sigma a minus sigma b by t equals to 0. So we have to derive by using standard relation pi is equals to t into p. So pi is equals to t, p is nothing but dE by dt. So rearranging, pi by t is equals to dE by dt. Differentiate. D by dt of pi of t is equals to d square E by dt square. So call this as equation number 1. We know that sigma a minus sigma b is equals to minus t into d square E by dt square. From the second relation, d square E by dt square is equals to sigma a minus sigma b by t minus as it is. From 1 and 2 will get d by dt of pi of t is equals to minus of sigma a minus sigma b by t. So if we take this to the left hand side, it becomes plus d by dt of pi by t plus sigma a minus sigma b by t equals to 0. Session summary. Student can able to explain heat absorbed due to the hot and cool junctions due to Peltier effect, and also know how to derive the expression for dE is equals to d pi plus sigma a minus sigma b into dt, and also to know to deduce the other four relations. Thank you.